Hello my dear students, welcome back to our channel Motivus. Today we are going to start another chapter. This chapter is again from class 11 NCRT, the first chapter, some basic concept of chemistry. In this part or in this chapter, we'll be discussing detailedly about what are the basics you have to understand in order to make your journey easier to crack the NEET exam. So here not only the NEET but also the JEE main too. So here we will be discussing the basic fundamental things first, then we'll be moving to the law of chemical combinations, mole concept, stoichiometry and limiting reagent, and finally we'll be discussing about the concentration terms. So this is how our chapter will go. So first we'll be understanding what is chemistry and what is its importance. Chemistry, of course, is a science of atoms and molecules. So it's a branch of science which deals with the study of matter, its composition and the changes that matter undergoes. Simply we can say chemistry is a branch of science which deals with the properties, preparation and structure of matter. And you know what is matter is, right? Matter is something which is having mass and occupies space. Fine, that is more than enough. And let's say if you go with the NCRD, a lot of things they have given how the chemistry evolved. They are talking about the elixir of life. They are talking about the philosopher's stone. That is somewhat very interesting. You can read that part. The elixir of life, the thing that will give you immortality, and the philosopher's stone, the stone that can convert all those metals into gold. So you can read that and come back to the important points in that they are discussing about some of the some of the inhaler some of the synthetic organic compounds that is very much helpful for our medicinal field, like all the drugs that are the part of the chemistry. Let's say about two drugs that they have mentioned in the NCRT, that is, we can say, Taxol and cisplatin. They are mentioning about Taxol and cisplatin, so that we are also mentioning Taxol and cisplatin. We are using it as anti-cancer drugs. Okay, for the cancer treatment we are using these two drugs, Taxol and cisplatin. And we are discussing about one other drug, azidothymidine. In short, we'll be calling it as AZT, that is used to help AIDS patients as well. So these are the two drugs, AIDS patients. These are the two drugs that they have discussed in this particular chapter. In the beginning, Taxol and cisplatin, and they are used as anti-cancer drugs, and azidothymidine, it is used to help AIDS patients. And of course we know the paracetamol and all the kind of stuffs we are using, all the drugs are from chemistry, right? So in this particular part, the basic ideas I told you, they are discussing initially. They are discussing about the SI units, system international units. You know what are the SI units, right? Length, that will be representing in meter, mass, that will be representing in kilogram, time in seconds, temperature will be representing in Kelvin, current I, that will be representing in ampere, the unit intensity, and that is representing in candela, cd, amount of substance, mole. These are the seven fundamental unit, and we got a lot of derived unit as well that you might have studied in your physics. Then comes another important part, precision and accuracy. What is precision and what is accuracy? You should know about this too. Precision is the closeness of various measurements for the same quantity. Let's say we are measuring for a particular quantity and we are measuring multiple times. The measurements are coming closer, then we can say that these are precise measurements. But that is not accurate. Accuracy is considered this measurement is considered as accurate when the average value of different measurements is closer to the actual value. The average value of the two measurements should be closer to the accurate value, but the precision it may not be the same. Like precision is just the closeness of two measurements. Even the average is not near to the true value, it doesn't matter, they are precise. But if it need to be accurate, the average should be coming closer to the true value. Let's find out it with an example. Let's say I'm measuring a quantity for 2 gram. You are measuring one and somebody else is also measuring. Let's find out. I'm measuring. No, you are measuring first. You are measuring first and you are getting a value like, let's say, 1.93 and 1.92. These two are the measurements you have taken. These two are very closer to each other, right? Yes, these two measurements are very closer to each other. And look at the statement of precision refers to closeness of various measurements for the same quantity. For the same quantity, I measured two, and these two come closer, and I can say that these two are precise. Whether their average is giving you 2, no, your measurements are wrong. It is not accurate. You cannot say it is accurate. And somebody else is measuring again. They are getting 1.94 one measurement and 2.28 some other measurement he is getting. And let's say, what about this one? They are, whether they are closer, they are not closer. Whether they are accurate, they are not accurate. So these two measurements somebody else have taken, we can say that this is nor precise, neither nor, right? Okay, neither accurate, neither accurate nor precise, we can say. Fine. Then your teacher, I'm gonna measure the values and I'm gonna get the value 2.05 and 1.99. Not 2.01. I'm measuring very good. 2.0. I'll erase this. I will erase this. 2.01. I am measuring and I got 1.99 and 2.01 as the measurements, and the average obviously is going to be 2 grams, right? 2, yeah, maybe, yeah, 2. Yes, it's very close. It is not only the average. If it is closer, then we can say that this is accurate. The true value is 2 gram, and I got values, two measurements, they are very closer to 2. So we can say that these two measurements are precise, and their average is 2 gram, so they are accurate. So my measurement is accurate and precise, and your measurement not accurate but precise. Somebody else is measuring, it is neither accurate nor precise. So you got the idea what is accuracy and precision. Yes, precision is closeness of various measurements, and accuracy is the agreement of measured value to the true value. We can say like that. Agreement of measured value to the true value. You can say like that. This is what is the difference between accuracy and precision. Let's find out the rules to determine the significant figures. Significant figures kandupidikkiradhukku what are the rules? Let's find out that. Okay, all non-zero are significant. All non-zero are significant. Let's say 2, 3, 4. How many significant figures you got? 3 significant figures. 0 before a non-zero is not a significant. Let's say 0.03. How many significant figures? You will be telling that it is 2, but no, it's 1. The 0 we are denoting just to identify the decimal point of this non-zero. So how many significant figures? Only 1. 0 before a non-zero is not a significant figure, but 0 in between non-zero. 0 in between non-zero are significant. So let's say 2.002. How many significant figures? 1, 2, 3, 4. 4 significant figures. So all non-zero are significant. 0 between non-zero is significant. 0 before a non-zero is not at all as significant. Then terminal zeros are not significant. Terminal zeros not significant. If you tell like this, there will be confusion. In this case, only one significant figures. But in this case, I have made a decimal point there. So you got three significant figures. Zeros, terminal zeros are not significant if there is no decimal. If there is decimal, that is significant. And counting the numbers, you got infinite significant figures. So counting the numbers or the object, you got infinite significant figures. So these are the major important things, important rules that you should remember while discussing about the significant figures. Then if you talk about the rounding off of the significant, non-significant figures. Let's say I wanted to round off 5.27. Look at that. This value is greater than 5. This value is greater than, okay, this value is greater than 5. If the value is greater than 5, then you can neglect this value and add 1 to this other value, so it becomes 5.3. Look at that. If the number is greater than 5, you can neglect this and add 1 to the nearby one. So let's say take 4.43. If this value is less than 5, oh man, if it is less than 5, you just neglect this, that's it. The value is gonna be 4.4. If it is less than 5, you just neglect it. And what if it is 5? What if it is 5? Let's talk about that. If it is 5, let's say 4.35. If it's 5 and before this 5 this is odd number, then you neglect this and add 1. So the result is going to be 4.4. What I have done, if it is 5 and nearby 1 it is odd number, I'm adding 1 unit to this odd number. And if you got 4.45, then this 5, before that 5, this is an even number, just neglect it, you are gonna get 4.4. This is how you have to do the rounding off for the non-significant figures. You got the point? If greater than 5, you add 1 unit to the nearby adjacent value. If the value is less than 5, you just neglect that. If the value is 5, check the next nearby value. If it is odd, add a unit to that odd number. If the value is even, then neglect it. Okay, this is what the rounding off. Exponential notation, let's say exponential notation, n into 10 power n. This is how the exponential notations are written. If we are not using exponential notation, you think about that, any number, let's say this velocity of light, speed of light is 3 into 10 power 8 meter per second. How will write this? 3 0 0 0 0 0 0 0 0, right? 1 2 3 4 5 6 7 8. I have to write like this. It's very difficult, right? So that is why we made that into scientific notation. The first number I have made 3, then into 1 2 3 4 5 6 7 8, 3 into 10 power 8 meter per second. This is what the use of this scientific notation. So let's say 0.0062. How many significant figures this will have? We know these zeros are not counted. This will have 2 significant figures. This will have 2 significant figures. Okay, now this can be written as 6.2 into 1 2 3 4, 10 power minus 4. Can you write like this? 1, 2, 3, 4. Correct? Yes. I can write it as 6.2 into 10 power minus 4. Look at that. How many significant figures? Two significant figures. So all the numbers can be represented in this exponential notation, or we can call it as scientific notation, n into 10 power n. What is this n value? N can be written as between 1.1 to 9.9. We can write it like this. This is 6.2. That's okay, right? This is how you have to represent the exponential notation. Now, come back to this matter. If we wanted to talk more, like let's say we got addition and subtraction. If you want to talk that, okay, we'll talk that too, no problem. Addition and subtraction. If you go for the addition, it's very difficult for the addition. You do the addition, I'll be telling you what is gonna happen, right? So if it is addition, you check the one which is having less decimal point, so the product also should have the less decimal point. Then if you go with the multiplication, 3.25 into 1.256, then you have to find out the product. What are the product is? It should have less significant figures. That is, either of the reactant, you have not the reactant. Again, the chemistry. I'm not good with the mathematics, but good with the chemistry, like it is. Okay, look at that. These are the two values that you are using, for the multiplication, and your product, not the product, the result. Yes, the resultant value should have the significant figures of the one which is having less significant figure. Now here the first one will have the less significant figure, the same number of significant figures should be there in the result. And here also, which one will have less decimal point, this one will have the decimal point, so the product also will have the same decimal point as this one. And here the result will have the same significant figure as that of this one. This is what is happening when you go for the subtraction and addition, or when you go for the multiplication and division. You got that? Yes, good. Now we'll come back to the classification of matter. Matter can be classified upon two methods, like we got the physical classification and we got the chemical classification. We got the chemical classification and we got the physical classification. Physically, we can classify that into solid, liquid, and gases. If you wanted to go broad, we can classify that into plasma and Bose-Einstein condensate. We are not going to talk about that. And still, we are not going to talk about the solids, liquid, and gases too. And here, in the physical quantities, the important thing what you have to remember is the conversion factors. Yes, we didn't discuss, and we'll be discussing about that before moving to this chemical. The conversion factors are important because we are going to measure the weight of the solid, we are going to measure the volume of the gas or liquid, we are going to measure the temperature. So these conversions are very essential. If you wanted to go with the conversions of volume conversions, you should remember that we have already discussed in the states of matter, but still we'll discuss 1 liter is equal to 1 dm cube, which is equal to 10 power 3 centimeter cube, which is equal to 10 power 3 ml, which is equal to 10 power minus 3 meter cube, right? Yes. If we go with the pressure conversion, what is the pressure conversion? Let's say pressure conversion, 1 atm is equal to 1.013 bar, which is equal to 1.013 into 10 power 5 pascal. Let's say that is equal to 760 mmHg. Let's say that is equal to 760 torr. Let's say that is equal to 76 cm of Hg, and it will go on. Like, and you know the temperature conversions, right? Temperature conversions are QT, temperature in Kelvin scale is equal to temperature in degrees Celsius plus 273, and Fahrenheit minus 32 into 5 by 9 is equal to degrees Celsius. These all conversions, I hope you know. Okay, fine. Now come back to the matter. What is our matter? Our matter is matter. What is matter? Matter is something which is having mass and occupy space. So matter can be classified into two based upon the chemical composition. Physically, we have classified that into solid, liquids, and gases. And in chemically we are classifying that into pure substance and mixtures mixtures will have variable composition. Yes, they will have variable composition. They are classified into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures, whether they are visibly distinguishable particle. That means if there is a mixture, they are telling mixture will have a variable composition. Just remember, composition will not be fixed. Composition will be variable for whom? For mixtures. And what about the pure substance? Matter can be classified into two, mixtures and pure substance. For the pure substance, there will not be any variable composition. Let's say it contains fixed composition. Okay. And for the mixtures, you'll have the variable composition. And the mixtures can be further classified into homogeneous mixtures and heterogeneous mixtures. In homogeneous mixtures, you cannot see different particles, but in heterogeneous mixture you can see different particles. Okay, homogeneous mixtures, we can say that components mix completely throughout the solution will be uniform throughout. But in heterogeneous it is not like that, components will not mix completely throughout the solution. And pure substance can be classified again into elements and compounds. Look at that, pure substance contain various type of atoms. No, not all pure substance. Pure substance can be classified into elements and compounds. Elements contain same type of atoms always. Like let's say about gold. Gold is an element, right? Whether gold contains copper? No. So gold element contains all gold atoms. That is what they are telling. And what about the compound? Let's say the compound, molecule of compound, water. Water contains two different atoms, right? Hydrogen atom, oxygen atom. So let's say it contains various type of atom. Yes. Elements contains atoms. Compounds contains, let's say, atoms இருக்கும். Atoms, the combination of atoms. So atoms of the same elements combines, let's say, we'll get molecules, and atoms of different elements combines, let's say, we'll get molecule of compound. And the pure substance we can classify into, as we have discussed, elements and compounds. Elements contains same type of atoms, and compounds will have the molecules inside that. And this is how it goes. Atom, how we'll be measuring the atom? How will be measuring the weight of the atom? That is through atomic weight. How will be measuring the weight of the molecule? Through molecular weight. We'll be this detailedly looking at what is atomic weight, what is molecular weight in the coming lectures. You don't have to worry. Just a brief idea I'm giving you. This is what your homogeneous mixture. I got a. It's not milk, it's water. Let's say water. What is this one? This is sugar. I'm going to take sugar, and I'm adding sugar into the water. I'm stirring this, and sugar, I'm adding to the water, I'm stirring this, and it's become homogeneous solution. If let's say I stir this, and this is what my sugar solution. Whether you can able to see the sugar separately? No. If I taste the sugar from here and from the bottom, the taste the same. So components mix completely. But if you talk about the heterogeneous mixture, let's say sand in water, you see the sand here below and the water, you can see that they are different. That is, they are in two phases, they are not mixing completely. So let's say the sand will be here and the water will be here. I'll taste some water from here, it will be okay. But I'll taste some water from here, I cannot taste that much water, I'll get sand from here, right? So you got the clarity between what is homogeneous and heterogeneous. Homogeneous, the components completely mix with each other, right? And heterogeneous, they won't mix with each other. And the major difference between the pure substance and this mixtures, pure substance cannot be separated by simple physical methods, but mixtures whether it is homogeneous or heterogeneous mixtures can be separated by simple physical method physical method let's say methods. Let's say this sand, I can take it from by simple hand picking. We can separate it doing do by filtration, by crystallization. So these are the simple physical methods we are telling. So mixtures can be separated by simple physical methods, and pure substance cannot be separated by simple physical methods. Then the next topic that we have to discuss in the next lecture is law of chemical combination. There are five important law of chemical combinations we have to discuss in the next lecture. These are very important. The first one is law of conservation of mass, given by Anton Lavoisier. The second one is law of definite proportion, given by Joseph Proust. And the third one is John Dalton's law of multiple proportion. And the fourth one, Gay-Lussac's law of gaseous volume by Gay-Lussac, and the Avogadro's law given by Avogadro. So in the next lecture, we'll be discussing detailedly about this law of chemical combinations. That's it for this session. We'll meet with another lecture. Thank you. Thank you very much.